guys are having a good morning, afternoon, night, whatever it is. Today we're going to talk about comparing and ordering fractions with unlike denominators. So if you miss class, the expectation is you take notes on this. So if you need to pause to write everything down, feel free to do that. If you're just watching this and you don't have me in class, or you don't have Miss Olson, well, just, enjoy. All right. So if we're going to compare and order fractions with unlike denominators, we need to figure out a way to make the denominators the same. So we're going to start by finding the least common denominator, or LCD, for the fractions in the set. So whatever fractions you have, we're going to make sure they all have the same denominator. After we find the denominator, we're going to write an equivalent fraction for each fraction in the set using the least common denominator. So we're going to convert them to a different form. And then finally, we're just going to compare the numerators, which is the top number. So after we convert them, we just compare them. This could mean putting them in order. This could be establishing which one's greater. This could be something like finding a fraction between them. You can always find a fraction between fractions. You just have to, maybe change that LCD a little bit. Okay, a couple examples now. Okay, in a recent survey, 3/5 of people like peanut butter and jam. It sounds weird, but peanut butter and jelly always sounds better to me. 1/3 like grilled cheese sandwiches. Compare 3/5 and 1/3 to find which food was the most popular. So if we go back to our procedure, first thing we're going to do is find the least common denominator, which means we need to find the LCM of the denominator. So let's go ahead and write those out just so we can see them. We have 3/5. So we have 3/5, and then we have 1/3. 1/3. Okay, so we don't really care about the numerator right now, so just kind of find those multiples of 5 first. So 5, 10, 15, 20, they keep on going. I think we have enough there. Let's find the multiples of 3. So we have 3, 9, 12, 15. I'm going to stop. I'm going to stop there because we have 15 in both lists. All right, which means we want to now convert the denominator, right, to a 15. Okay, so how do we do that? Well, we've actually done this a couple different times. So let's start with the 3/5. All right, so give myself some space here. I know that I want to change the denominator, the bottom number, to 15, right? So, okay, in order for me to do that, right? Oh, I just realized I forgot a 6 here. I'm just going to add that. Bad, Mr. Robinson. All right. In order to get the 5 to 15, I have to multiply it by 3. So I'm going to do the same thing on the top. I'm going to multiply that 3 by 3, and that's going to become a 9. So I know that 3/5 is the same as 9/15. All right. Now I'm going to do the same thing for 1/3. Say 1/3. I know I want this to equal something over 15, right? So I know that 3 times 5 equals 15, which means I need to multiply the top by 5. 1 times 5 is 5. So I know that 1/3 is 5/15. Now if I look at this, now I want to just look at those numerators. So I have 9 and I have 5. 9 is very clearly a greater value than 5. So I could say, now I can pretty confidently say that 3/5 is greater than 1/3. Now, there's other ways to do this as well. Like, for example, a lot of you will realize that 3/5 is greater than half and 1/3 is less than a half. And that's another way you could logically say that 3/5 is greater than 1/3. With that being said, sometimes, especially when you get fractions that are both below a half or both above a half, it's a good idea to have this trick in your tool bag. All right, let's go ahead and look at another question. Oh, and of course my OneNote has to bug out, so we're just going to kind of ignore that for a second until it cleans itself up. Okay, list the following fractions from least to greatest: 1/2, 1/6, 1/3. All right, so first thing we're going to do is we're going to find multiples of all these and find the least common multiple. So let's start with 2. I'm going to list the first 5. Hopefully we'll find it before then. 2, 4, 6. I forgot an 8. 8, and then 10. All right, and I'll do 6 next. Let's because they're in order. 6, well, we already have a common multiple there. Hopefully that'll work out. 12, 18, 24, and then finally 30. So just realize when you're looking at these, this is basically 1 times 6, 2 times 6, 3 times 6, 4 times 6, 5 times 6. You can actually use that later when you're converting it. Okay, now with 3, we have 3, 6, 9, 12, and 15. Now, usually I would stop when I got to the 6 because I know there's a 6 in this list, there's a 6 in this list, and there's a 6 in that list. All right, now we're going to go ahead and do what we did in the last problem and convert those. So let me start with 1/2. So 1/2 equals something over 6. I know that to get from 2 to 6, I have to multiply by 3. Multiply by 3. So this would be 3/6. Now let's do the same thing with 1/6. Guess what? I'm actually done already. It's already in 1/6, so I can just say 1/6, done. Let's do that with 1/3. So 1/3 over 6. Let's multiply that by 2. So I'm going to multiply the top by 2 as well. I have 2/6. So it appears that 1/2 is 3/6. Right? Then it appears that 1/3 is 2/6, and 1/6 is obviously 1/6. There's no mystery there. So if I put them in order based on the converted fraction, we have 1/6, 2/6, and then 3/6. Now, we're not quite done because we know that we can reduce 2/6 and 3/6. So let's go ahead and write them in their original forms now. So if we were to have these in order, we'd have 1/6, and then we would have 1/3, right? 1/3, and then finally we would have 1/2. So in order from least to greatest, we have 1/6, 1/3, and 1/2. And we figure that out by converting the denominator to the least common denominator and then changing the numerator accordingly. All right, one more example. All right, so find a fraction between 1/6 and 1/2. Now the reality is there's an infinite number of fractions between 1/6 and 1/2. We just need to find one. Okay, so I'm going to go ahead and list the multiples of 6. So 6, 12, 18, 24, and 30. You guys might be thinking, nah, Mr. Robinson, I already know what it is. Why are you listing these? That's fine. It's just good practice. 2, 4, 6, 8, and 10. If we look at our list, we see a 6 here, and we also see a 6 here. That's great because that means 1/6 is already in simplest form. All right, and then to convert 1/2, we're going to do the same thing we did before. 1/2 equals blank over 6. So I multiply that by 3, multiply the top by 3 as well. I get 3/6. So now we have 1/6, and we're trying to find something in the middle, and then we have 3/6. Okay, so if we look at this, we see that we have a 1 and then a 3. So it'd be logical to say that we could go ahead and say that 2/6 is in the middle of these two numbers. So basically repeating what we did before. Okay, now let's just pretend, let's extend this now. Let's say we're trying to find a number between 1/6 and 2/6. How can I do that? Well, if you want to do that, what you're going to have to do is make the denominator bigger. So pick any number. Doesn't really matter what. Let's say I want to convert 1/6 to, I know the next multiple of 6 is 12. So I can go ahead and just convert that to a 12th by multiplying that by 2. I'll multiply the top by 2. So I get 2/6. All right, so if I want to do the same thing with the green number, once again, I can use the next counting number, and I can use 12. So I know that 2/6 is going to equal 12 over 4. In which case now we can once again determine that, we can say that 3/12 is between 2/12 and 4/12. By the way, 3/12 would be 1/4. Now, if you wanted to, you could keep doing this forever, and you could always find a fraction between a fraction by changing that denominator and then adjusting the numerator accordingly. All right, thanks for watching. Have a good one. And as always, I don't have anything to say. I'm out. I don't got anything.